So David, can you share a little bit of your views, your personal views with regards to solar energy as well as electrical vehicles?
Certainly. Look, it's really exciting. I'm actually looking forward. I'd love to buy an electric vehicle. In Australia, we're slowly starting to adopt that. I know here in Malaysia, there's some really aggressive plans to get EVs, more EVs into the market space. But not only is that exciting, but it's also scary, because I'm really worried about the distribution network. We're going to now, be adding this increased load at the MV and LV side of things. So things like power quality, balanced load across all the phases is going to become, a big challenge for these networks. And we're working with quite a few in Australia and New Zealand at the moment. If you could imagine, when you come home at the moment, you traditionally would put the kettle on, maybe you'll watch TV, maybe you'll put some washing on. The network's designed for those loads at the moment. Now we're going to go and then add an EV charger. So the first thing you do when you come home is you're going to go and plug in your charge, and you want to get a fast charge because you want to go out to the shops later. That's going to be a massive load on the distribution network. And most networks aren't ready for that. They don't have visibility at the MVLV. For years we've had SCADA and things at transmission, but at that end, we just don't have that visibility. And some networks don't even have smart meters. So we're working on a really exciting project in Australia at the moment. It's government funded, and we're working with a combination of smart meter data, MV data, and car chargers. So I guess if you can imagine your street, you've got a number of houses, and at the end of the street you've got a small distribution transformer that's providing energy into the street. And so what we're doing is we're putting a transformer monitor on that pole top transformer. So we're looking at how much load is on there. So we're seeing when the customers come home and they put their kettle on and they turn the TV on. So we have a visibility of the load on that distribution transformer. Then at the other end, every customer has a smart meter, and so we can see the load at the individual user at the individual house. And so what we're doing is we're taking that smart meter data, we're pumping it into the cloud. We're taking data from our power transformer, we're putting that into the cloud, and what we're doing is we're determining how much power can I get through that transformer. So we're looking at things like, can I run, if it's a cold day and I've got really good cooling effect, can I run that transformer harder? Can I get more power out of it? Or can I export more power to my customers and charge them more? But part of that is, if everyone starts coming home and everyone wants to charge at the same time, we're not going to be able to run those chargers at full rate, at full fast charging. So we need to make some really smart decisions, and our algorithms that we're developing with that customer will do that. So what we can actually do is, if there's a significant load on that transformer at the moment and we're at risk at damaging or overheating that transformer or the network itself, we can actually send a command to those car chargers and turn them down. So we can actually slow the charge rate so that everyone on that street gets to enjoy charging their cars, but just at a slower rate, without putting any damage or getting an outage on the network. So those sort of projects are really exciting for us.
So would the entire process comply with the latest, directive from in the world's view with regards to environmental as well as the social and governance?
Look, I think so. Anything we can do to encourage and speed up the adoption of EV and even putting in solar on your house, I think is a positive thing for the environment.